class. This is Ms. Martins. I'm hoping everyone is doing well. All information needed for this course will be uploaded to Google Classroom. You can also communicate with me using Google Classroom if you have any questions or if you have any trouble. I'm also available via email if you would like to do that instead. There will be a weekly syllabus uploaded on Google Classroom as well. That'll tell you everything that you need in order to be successful for this class online. For now, I will be recording my voiceover using PowerPoint presentations in order to teach you, but I will be constantly looking for better ways to give you guys information, whether it's worksheets or me going live. This is new for you and this is new for me as well, so we're going to work with each other in order to be successful in this realm. So with that being said, the Unit 6 stoichiometry exam will be going live this Wednesday, but I will be giving you guys until Friday to complete it. To complete it, but once you open it, you have to finish it. The Unit 6 stoichiometry exam includes type of chemical reactions, balance and equations, law of conservation of mass, molar mass, gram formula mass, percent composition, and today's lesson will be the last topic. So make sure that after you go through today's lesson, you'll review, I'll post review stuff for you guys. You can review all these previous topics so that you guys can be familiar and successful with the exam. So let's jump right into today's lesson. Happy Monday once again. So once again this week, today we're going to be doing moles to moles. Unit 9 review will be tomorrow. I'll upload a lot of Google Forms with different types of practice questions for you guys to complete. And Wednesday, the Unit 9 exam will go live. Thursday and Friday, we'll be going into a new unit. That information will be provided for you guys on the weekly syllabus if you would like to get your work done a little early. Today's objective, students will be able to use mole ratios to determine moles of reactants and products in a balanced reaction. So make sure that you guys review how to balance a reaction. Remember, for a reaction to be balanced, the elements on the reactant side must be equal to the number of elements on the product side, right, for a specific element. So we're going to refresh how to count moles. We're going to start off with this compound or this molecule called phosphate, PO4. How many moles of phosphorus are there in this compound, in this molecule? So there is a subscript of 1, therefore there is going to be 1 mole of phosphorus. For oxygen, there's a subscript of 4, therefore there's going to be 4 moles of oxygen. So once again, there's 1 mole of phosphorus and 4 moles of oxygen. But in terms of the entire compound, there's 1 mole of phosphate, which is the entire compound. Whereas with this equation, this formula, we have a coefficient of 3, right? So phosphorus still has a subscript of 1. 1 times 3 equals 3 moles of phosphorus. The entire compound, chemical formula, phosphate, there's going to be 3 moles of phosphate. And because of the coefficient, you're going to multiply 4 times 3 to get 12 moles of oxygen. So this, counting the moles, is the same thing, essentially the same thing as counting how many atoms of each element are in the compound. So to refresh that, there's 3 moles of phosphorus, 12 moles of oxygen, and 3 moles of phosphate, the entire compound. This is due to the coefficient. So I'm just going to review that again. This formula is different from the first formula because this formula has a coefficient of 3. There are 3 moles of the entire phosphate, the entire compound. There's 3 moles of phosphorus because of this coefficient 3 multiplied by this subscript 1. And then there are 12 moles of oxygen because it has a subscript of 4 and a coefficient of 3. So we're going to go through this first question together. Given the reaction N2 plus 3H2 yields 2NH3, what is the total number of moles of nitrogen gas, N2? So how many N2 do we have within this chemical equation? There is no coefficient before N, so we're going to assume that we only have 1 mole of the entire molecule N2. So N2 is a molecule within itself, which is stating that there are 2 nitrogens. However, we have 1 mole of that entire molecule, N2? So the answer is 1. Take time to read this question and understand why we got the answer that we got. All right, so I accept an example. I'm going to give you guys time to read it and figure an answer on your own. Okay, so it states, given the reaction, the same reaction as before, N2 plus 3H2 yields 2NH3. Sorry, that question mark is supposed to be an arrow. What is the total number of moles of hydrogen gas H2? So how many moles of hydrogen gas H2 do we have? If you answered 3, you are correct. Because of the coefficient of 3, there are 3 moles of the entire molecule H2. If they asked how many hydrogens there are, then there are 6 hydrogens. However, there are 3 moles of hydrogen gas, H2. So with this question, I'm going to give you guys time to answer it on your own. Given the reaction N2 plus 3H2 yields 2NH3, what is the mole-to-mole ratio between nitrogen and hydrogen gas? So how many moles of nitrogen do we have? And then compare that to the moles of hydrogen we had. The previous question asked us how many moles of nitrogen we have, which is 1. And then the question after that asked us how many moles of hydrogen we have, which is 3. So you're just going to put that in a ratio format, which is 1 to 3. If you answered choice 2, you are correct. Once again, if you have any questions, if any of this seems difficult for you, just write in the comments section of the Google Classroom. You can post the question up and I'll feel free to answer you. Your peers can even answer if they would like. Once again, 1 mole of nitrogen, 3 moles of H2, giving us that ratio of 1 to 3. Our next example. So we have aluminum plus oxygen is giving us aluminum oxide. The question is, what is the total number of moles of oxygen that must react completely with 8 moles of Al, right? So we currently have 4 moles of aluminum and 3 moles of oxygen. And then this creates 2 moles of aluminum oxide. However, we want to have 8 moles of aluminum. So how would we get to 8 moles of aluminum? Think about that. How could you go from 4 to 8? So currently we have 4 moles of aluminum and 3 moles of oxygen. How do you get from 4 to 8? If you guessed multiplying by 2, you are correct, right? So then what would we need to do to oxygen in order to figure out how much oxygen we would need? You would need to multiply oxygen's moles by 2 as well, and you get 6. So 3 times 2 equals 6. So the question states once again, what is the total number of moles of oxygen that must react completely with 8 moles of aluminum? 3 times 2 equals 6. So we need 6 moles of oxygen in order to react completely with aluminum. Take some time to answer this question on your own. Also, you can be following along on the guided note sheet. I kind of said this late in the video, but there is also an attached sheet that has all of these questions written out on it. So you could follow along there. I will post that along with this video in the beginning, so hopefully you get that information a little earlier. Take some time to try to answer this question on your own. All right, so given the reaction, calcium plus water yields that question mark once again is an arrow. The products, calcium hydroxide plus hydrogen. How many moles of water are needed to react completely with 2 moles of calcium? So we're starting off with 1 mole of calcium and 2 moles of water. And they're asking us, if we start off with 2 moles of calcium, how many moles of water will we have? So we have 2 moles of calcium. In order to get to 2 moles of calcium, you would multiply the coefficient of 1, that's their imaginary, times 2. And then if you multiply calcium by 2 to get 2, then you have to multiply water by 2. And if you multiply the coefficient of water by 2, which is 2 times 2, you'd get 4. So once again, calcium originally has a coefficient of 1 because there's nothing there, but they tell us that there are 2 moles of calcium within this reaction. How many moles of water are needed? So we initially start off with 2 moles of water. In order for it to be consistent with calcium, we'd have to multiply the coefficient of water by 2 as well, and 2 times 2 is equal to 4. All right, so hopefully that helps. Feel free to watch this PowerPoint video as many times as you need. There are going to be Google form practice questions that need to be completed along with this video. If you need help, feel free to ask. You could post any of the questions. Watch this video as many times as you need to. Ask your peers for help. There's YouTube as well. I'll post some links up hopefully